Yesterday, I was giving you the different cases here. Already in that video, I have given the different case here. And today in this free body diagram, its next part, see, where two bodies connected by a string passing over a smooth pulley. Then, how can we apply the Newton's second law of motion? And how can we derive the expression for the acceleration of these masses as well as the tension in the string? Suppose this one is a smooth pulley. And smooth pulley means here friction is not present in this pulley, or friction is here no friction in this pulley, frictionless pulley here. And suppose a string is passing over this frictionless pulley, and from the end of the string two masses M1 and M2 are attached. And here I am considering suppose M1 is greater than M2. हम मान लेते हैं कि मास M1 M2 से बड़ा है. So when it is free, then this mass M1 will move downward and this mass M2 will move upward. And remember this, if the mass M1 will move downward with the acceleration A, then this mass M2 will move with the same acceleration A in what direction? Upward. And you know, when this mass will start to move, then this string becomes tight. ये string क्या हो जाएंगी? ये tight हो जाएंगी. Tight means a tension is developed in the string. And now you see here, how can we find the expression for the acceleration of these blocks, as well as how can we find the tension in the string? So remember this. This one is a string, और याद रखिएगा, this one is a single string. ये single string है. And if string is single, then tension in each segment will be remain same. इसके हर एक सेगमेंट में टेंशन क्या रहेगा? सेम रहेगा. अगर सेम strings passes through this. So in this case, the mass of this block is M1. So its weight M1g will act downward, and this string becomes tight. So a tension is developed in the string which will be act in what direction? Upward. Similarly, for this mass M2, its weight M2g will act downward, and tension in this segment will also act in what direction? Upward. And both tension are same. Why? Because the same string is passes over the pulley. And now you see, when you will draw a free body diagram for this mass M1, so you can say free body diagram for M1. How can you draw it? Free body diagram for mass M1. Look here. This one is mass M1. Its weight M1g will act downward. Tension T in this string which act on this mass M1 will act upward. And acceleration is acting in what direction? Downward. It means how many forces acting on this mass M1? How many forces? Two forces. Weight as well as through this string, a tension is also acting on it. But M1g is acting downward and tension is upward. But out of these two forces, M1g weight is a force. So out of these two forces, M1g and T, which one is act in the direction of acceleration? तो कहोगे M1g is act in the direction of acceleration. इसका मतलब M1g बड़ा होगा किससे? इस टेंशन T से. So what is the net force on this mass M1? So you will write M1g minus T. So what equation? You will write here for motion of M1. What expression you will write? Net force M1g minus tension is acting opposite to it. So this M1g minus T. This one is the net force acting on this mass M1. In what direction? Downward. And according to Newton's second law of motion, this net force is equal to its mass into acceleration. Similarly, when you will draw the free body diagram for the mass M2, Now you consider free body diagram for M2. So suppose this one is M2. Here you will take this one is M2G. Now acceleration is acting upward, M2G, and this one is tension. Now you see M2G, tension T upward, and acceleration is A. Again, how many forces acting on this mass M2? Two forces, M2G and T. But acceleration is acting in the direction of tension T. It means T is greater than M2G. So what is the net force acting on this mass M2? T minus M2G, and this net force T minus M2G is equal to M2A by Newton's second law of motion. So you can say for motion of M2, what expression you write? T minus M2G is equal to M2A. Suppose this equation. And in this way, you will get the expression for motion of mass M1 as well as for the mass M2. And when we add on adding 1 and 2, on adding 1 and 2, when you will add the equation 1 and 2, तो लेफ्ट हैंड साइड पर टोटल ऐड कर लीजिए, तो m1g माइनस टी प्लस टी माइनस m2g is equal to m1a plus, you will write here, m2a. You will write m1a plus m2. Now this plus t is cancelled by minus t. And here you will write m1g minus m2g is equal to, take a common, so you will write here m1 plus m2 into a, or you can say here m1 minus m2. You can also take g common here, is equal to m1 plus m2 into a. So a is equal to m1 minus m2 g upon m1 plus m2. In this way you can find out the expression for the acceleration of the block m1 and m2. इसी acceleration से block m1 नीचे जाएगा, and with the same acceleration a, the block m2 will move upwards. And for finding the tension in the string, how can you find the tension? So from equation 1, this one m1g minus t is equal to m1a, you can say t is equal to, from equation 1, t is equal to, you can write here m1g minus m1a. In this way, m1g minus m1a is equal to this one. Or you can say t is equal to m1, take common, and here you can write g minus a. Or simply you can say, sorry, here m1g minus m1a, m1g minus m1, at place of a write on this one. So m1 minus m2 into g upon m1 plus m2. m1g and this one. Now t is equal to, look here, this one is m1g, here also m1g. Take m1g outside, and here you will get 1 minus here m1 minus m2 upon m1 plus. And finally you will get t is equal to m1g, and here you can write m1 plus m2, m1 plus m2 minus m1 plus m2 upon m1 plus. Take the LCM m1 plus m2, you will find out this one. plus m1 is cancelled by this one, and you will get T is equal to m1g, m2 plus m2, 2m2 upon m1 plus m2. And in this way you will get T is equal to 2 m1 m2g upon m1. So in this way you can derive the expression for acceleration of that block as well as the tension in the string here. So suppose if numerical problem is given, then direct also you can use this formula, or you can write the expression for first motion for mass m1 and m2, and then you solve it for the acceleration as well as for the tension. Now next case, two bodies connected by a string, and out of these two, one body placed on a smooth table. Suppose this one is a smooth table and this one is a frictionless pulley which is attached to one corner of this table, and a mass m2 which is placed on this smooth table, and a mass m1 which attached with mass m2 through a string which is passed over this smooth pulley. And suppose this mass m1 is greater than mass m2. मास m1 हम मान ले रहे हैं मास m2 से ज्यादा है. And when mass m1 is greater than mass m2, so suppose this mass m1 is moving downward with the acceleration a, then this mass m2 moves on this table with the acceleration a. So now you see here, weight of this mass m1, m1g will act downward, and this string becomes tight, so tension is act upward. And weight m2g of this mass m2g act downward, normal reaction are upward, and tension in this string, याद रखिएगा वास्तव में है क्या ये, this mass m1g when moves downward, then it pulls this mass m1. It means this tension is acting on mass m2 due to mass m1. ये मास m1 इस मास m2 को इस टेंशन T से अपनी तरफ खींच रहा है थ्रू द स्ट्रिंग, एंड फॉर एवरी एक्शन देयर इज इक्वल एंड अपोजिट रिएक्शन. तो ये मास m2 भी इस मास m1 को सेम टेंशन T से अपनी तरफ खींच रहा है. सो दिस T इज एक्ट ऑन m1 ड्यू टू m2, दिस T इज एक्ट ऑन m2 ड्यू टू m1. एंड नाउ यू सी, when you will take for motion of mass m1, for motion of m1, here if you want then you can also draw the free body diagram, but direct also you can write free body diagram में लेंगे क्या होगा, बस इतना बनाएंगे आप अलग से इसको. तो how many force is act on this mass m1? Two force, one is m1g, other is T. Acceleration is acting in the direction of m1g, it means m1g is greater than T. Net force on this mass m1 is m1g minus T, and this net force is equal to mass into acceleration by Newton's second law of motion. This one for the motion of mass m1. Similarly, when you write the expression for the motion of mass m2, for motion of m2, how many forces acting on m2? There are three forces which are acting on m2. Its weight m2g downward, normal reaction are upward, and this tension T. और मैं बता दूं कि ये तो स्ट्रिंग सेम ही है, इसलिए इसमें और दोनों सेगमेंट में टेंशन भी क्या है, इसका सेम है. और याद रखिएगा ये टेंशन थ्रू द स्ट्रिंग लग रहा है क्योंकि ये मास m1 इस मास m2 को खींचेगा through this string, means a tension through a force which is developed in this string. And for motion of mass m2, m2g downward, normal reaction upward, tension T in this direction. But you see here, out of these three forces which is acting on the mass m2, neither this block is moving upward nor downward. It means these two forces are balancing to each other. ये दोनों फोर्स आपस में एक दूसरे को क्या कर देंगे, बैलेंस कर देंगे. इनका मोशन के लिए कोई रिस्पॉन्सिबिलिटी नहीं होगी. नाउ विच फोर्स इज रिस्पॉन्सिबल फॉर द मोशन? अब बचा कौन? tension T, and this T is acting in the direction of acceleration. It means this T is responsible for this motion. So what expression you write? Force T is equal to mass m2 into A. Force is equal to mass into acceleration by Newton's second law of motion. So adding equation 1 and 2, इन दोनों इक्वेशनों को ऐड कर दीजिए. What you will get here? m1g minus t plus t, दोनों के लेफ्ट हैंड साइड को एक साथ जोड़ दीजिए, इज इक्वल टू राइट हैंड साइड को एक साथ जोड़िए, m1a plus here plus t is cancelled by minus t. You can write here m1g is equal to m1 plus m2 into a, and m1g is equal to m1 plus m2 into a. So you can say a is equal to, you can find here, so a is equal to m1g upon m1 plus. So in this way you can find the expression for the acceleration of these blocks. And remember this, the acceleration with which this block m1 will move downward, with the same acceleration this mass m2 will slide on this smooth level. And how can we find the expression for the tension in this string? So from second equation T is equal to m2a, from equation 2 you can write T is equal to m2a, and you can write this is equal to m2 at place of a, and this way you can find out the expression for the tension in the string here. So in same way also you can derive the expression for others problem also. It not necessary here. Also you can take one more block this side here. एक पुली यहाँ लगा दीजिए और उसके नीचे भी यहाँ से एक स्ट्रिंग लगा के रख दीजिए और कह दीजिए सबसे बड़ा मास है, ये ऊपर जाएगा, ये राइट हैंड साइड, दिस वन इज. तो यू कैन आल्सो फ्रेम द एक्सप्रेशन फॉर द motion of the different blocks on the smooth surface, or the block passes through a pulley which is attached through a string. Now next topic is concurrent forces, and by definition, if the forces applied to a body are such that their line of action meet at a single point, then these forces are called concurrent forces. अगर किसी बॉडी पे कई फोर्सेस काम कर रहे हों लेकिन सब फोर्स एक ही पॉइंट से काम कर रहे हों, तो आप क्या कहेंगे? ये सारे फोर्सेस जो हैं कौन से फोर्स कहलाएंगे? कॉन्करेंट फोर्सेस. जैसे हम कहें, इफ सपोज XY इज ए प्लेन एंड थ्री फोर्सेस F1, F2 and F3 will act, and their line of action meet at the same point O. चूंकि O से F1 भी है, F2 भी है, F3 भी है, then you can say this F1, F2 and F3 are the concurrent forces because their line of action meet at the single point, or you can say at this point, same point. And if the resultant of these forces is vector R, then you can say this vector R is equal to vector sum of these forces F1, F2 and F3. So you can say concurrent forces, their resultant R is given by vector F1 plus vector F2 plus vector F3. ये इनका वेक्टर सम है फोर्सेस का, न कि अलजेब्रिक सम. और जैसे हम कह दें कि if the several force is acting on a body and body is in equilibrium, if the several concurrent forces if the concurrent forces are acting on a body and the body is in equilibrium, इसका मतलब सभी फोर्सों का वेक्टर सम जो R आ रहा है रिजल्टेंट फोर्स, वो क्या आ रहा है? 0. If the several force is act on a body but the body is remain in rest or body is in equilibrium, it means the vector sum of all these forces is equal to 0. So how can we define the concurrent forces? if the forces applied to a body are such that their line of action meet at a single point, सभी फोर्स एक ही पॉइंट पे अगर काम करते रहें, तो उनका लाइन ऑफ एक्शन अगर एक ही पॉइंट पर है, तो ये सभी फोर्स क्या कहलाते हैं? कॉन्करेंट फोर्सेस. Now, equilibrium of the concurrent forces. Under what condition the concurrent forces will be in equilibrium? Suppose if the three forces F1, F2 and F3, and suppose these three forces are concurrent forces, and these forces are said to be in equilibrium if the vector sum of any two force is equal and opposite to third force. अगर जैसे थ्री कॉन्करेंट फोर्सेस आर इन इक्विलिब्रियम, तो इन तीन में से किन्हीं दो फोर्सों का वेक्टर सम जो है वो इक्वल और अपोजिट हो जाए थर्ड फोर्स के, तब कहेंगे कि ये टोटल क्या हो जाएगा? इक्विलिब्रियम में. या कहते हैं कि सभी फोर्सों का वेक्टर सम किसके बराबर हो जाएगा? तो जीरो के. कैसे? देखिए, सपोज F1, F2, F3 are the concurrent forces. Why? Because it fulfill the condition of concurrency. What? All these three forces meet at the single point. And if the resultant of any two force, suppose resultant of F1 and F2 is vector F1 plus vector F2 by the law of parallelogram, which already I have discussed in the vector law of addition, parallelogram law से इनका और इन दोनों का रिजल्टेंट मान लीजिए ये हो गया वेक्टर F1 plus vector F2. Now, if this force F3 is opposite to F1 plus F2 and the magnitude of F3 is equal to the magnitude of F1 plus F2, तो कहेंगे नेट फोर्स यहाँ क्या आ जाएगा? जीरो. So you can say for equilibrium, you can say here F1 plus F2. ये फोर्स F1 plus F2 क्या होना चाहिए? Should be equal to force minus F3. Minus F3 का मतलब F1 plus F2 और ये F3 फोर्स का डायरेक्शन क्या होना चाहिए? अपोजिट. और दोनों का मैग्नीट्यूड क्या होना चाहिए? बराबर. R you can say here vector F1 plus vector F2 plus vector F3 should be equal to 0. It means three forces are said to be in equilibrium if the resultant of any two force is equal and opposite to the third force. And in this way, the total vector sum of all these forces should be equal to 0. Then you can say these forces are in equilibrium. So today you go through this topic, what I have discussed in the Newton's law of motion, and also you go through all the example of this exercise, short answer type problem, very short answer type problem, and also you try to solve some numerical problem which is given at the end of this chapter. And now today this chapter is over. From next time I will discuss some problem based on it, and then I will discuss the next topic or next chapter. Thank you.